Hello, and welcome to Programming with Python for Scientists and Engineers. I'm Karen, and this is Josh.
Today we're going to look at three very important Python packages that all make heavy use of NumPy.
Matplotlib, SciPy, and Pandas are all great tools for scientists and engineers. Let's start with Matplotlib, a package that can be used to make nice data plots.
Matplotlib provides a full complement of plot types, including line plots, scatter plots, histograms, bar charts, pie charts, and contour plots. Several examples of plots and the source codes are available in the gallery at the matplotlib.org website. We will go through three examples explaining some of the techniques for creating and customizing the plot displays.
First, we'll try a simple plot. In Spyder, create a new file and type the following. And run it.
Linspace is a function in NumPy that creates an array of evenly spaced values between and including a start and an endpoint. In this case, from -4.0 to 4.0. The third argument specifies the number of intervals used to cover the range from start to end.
Because you have an IPython console, the plot appears in it when the plt.plot of xy statement is executed.
Now let's make fancier plots. Type in and run this example from the Matplotlib documentation.
So, let's talk about what this code does. First, the code generates our values to plot x1, y1 and x2, y2.
Then it sets up the first of two subplots. In the plt.subplot statement, the first two arguments specify how we want the subplot arranged. In this case, 2 rows, 1 column. The third argument indicates which subplot is to follow. This time, we do count from 1, not 0.
The plt.plot function creates the actual first subplot of the damped oscillation values, x1, y1 first. The argument yo- says we will use yellow for the color, circles for the points, and lines connecting the circles.
The title for the entire subplot should be included with the top subplot. Otherwise, the title may be inserted between the two subplots.
The Y label specifies the label for the vertical axis.
The code moves on to the second subplot. The undamped values x2, y2 are plotted in red using dots for the points and connecting the dots with lines.
The label for the x-axis, for instance x label, is placed beneath the axis. Now we know a lot about making line plots.
Next, we want to make plots of functions of two variables, f of xy. When plotting functions of two variables, we generally treat the xy plane as a mesh grid and define our function values at the intersection points of the grid. Fortunately, Matplotlib has tools to make this task easier for us.
We'll look at a contour plot first.
Let's look at this example in more detail.
The code creates evenly spaced values for x between -2π and 2π, and for y between -4π and 4π.
Next, it creates a mesh grid for the values. The 2D arrays, capital X and capital Y, are created with replicated values of lowercase x and lowercase y. Specifically, the column capital X colon I in brackets would be filled with the value lowercase x I in brackets, and the row capital Y J colon in brackets would be filled with the value lowercase y j in brackets. Both dimensions are needed to ensure that the code correctly computes and plots the values for all cross-sections of the mesh grid.
Using the element-wise feature of NumPy functions, the values of capital Z can be computed as a function of capital X and capital Y.
Finally, the capital X, capital Y, and capital Z matrices are passed to the contour function for plotting.
If you want the contours filled in with color, simply type the following.
Finally, we'll make a surface plot using the same capital X, Y, and Z matrices from the contour plot. This is a little more complicated since we first need to inform the interpreter that we are creating a figure with a set of 3D axes. Then we can plot the surface onto those axes.
Let's type the following.
These are just a few examples of the many things you can do with matplotlib. Now, let's look at another set of packages that you should know about, SciPy.
The name SciPy comes from the words scientific and Python. So, you might guess it's full of useful functions for scientific computation. There's a great tutorial at the scipy.org website that you may want to check out. To use SciPy, you will also need to import NumPy. We usually import matplotlib as well. The tutorial assumes that we've already made the following imports.
Let's go through one example to show you how it works. There is a base SciPy package, but most of the functionality is in individual subpackages that we have to import. We have packages for special functions like Bessel functions, packages to integrate, packages for optimization, for linear algebra, and several others. It can even do simple image processing with the NDImage subpackage.
There are many more subpackages than we have time to discuss. Just as an example, let's look at how to use SciPy to solve a system of linear equations. Here's the system we want to solve.
We can rewrite this into matrix form like this. The code to solve this system uses the linalgsolve function from SciPy. So type the following. For this example, you can use your IPython console. You should get the following result for x. Wow, it's that easy.
Now let's look at another important package. Pandas is the Python data analysis library, and it has many statistical functions built in. You can find documentation at pandas.pydata.org.
To use pandas, we will need to add it to our imports.
The most important new data type in pandas is the data frame. A data frame is a little like a generalized array. It's particularly useful to store data that's in a spreadsheet format. The columns are labeled with strings, while the values are stored in something similar to NumPy arrays.
Eventually, you will learn how to read data into a data frame using pandas, but for now, we will use a data set that comes with a plotting package called Seaborn and explore how we can manipulate a data frame. Seaborn is not installed into your Anaconda bundle by default, so we'll install it. Shut down all the Python environments you may be running. Open the Navigator and go to Environments. Find the drop-down labeled Installed and change it to Not Installed. Scroll down to Seaborn, click on it, and select Mark for Installation. Then, hit the Apply button at the lower right. This may take a while, so you may want to pause the video.
When it's finished, hit the Home icon. Start up the Qt console. This is a separate IPython console that's useful for data exploration. Import NumPy, matplotlib, and pandas again. Now, import Seaborn.
Now load the Iris dataset. This is a dataset from the 1930s on traits of various iris cultivars. Type this. This shows you the column names and the first few lines of data.
Next, type iris.tail20 in parentheses. This shows you 20 rows rather than the default 5. Iris.columns is just the column names. Iris.values is the values. The dtype equals object is a special type that is more general than a number.
If we type this, iris.describe parentheses, it shows us interesting summaries of the properties of the data. To extract the column labeled sepal width, run the following. This is a pandas data type called a series.
To store the rows that represent numbers into a NumPy array, use a function called iloc.
Now try iris.mean parentheses. This shows you all the results for which it makes sense, but Suppose I want to get the mean for each species in my dataset separately. Type this.
Just to give you a taste of the power to plot your data, run the following. To exit the Qt console, either click the Close button or type quit parentheses. In this episode, we learned about 3 packages that are widely used for scientific and engineering computing: Matplotlib for data visualization,
SciPy to solve advanced mathematical problems,
and Pandas for sophisticated management and manipulation of multi-dimensional datasets that extend typical array functions.
Make sure to perform the assignments attached to this episode.
Thanks for joining us for this episode of Programming with Python for Scientists and Engineers. See you next time.